It's a trapezoid. Ha ha ha. As our wonderful Admiral Akmar has helped us talk about, we are going to be discussing trapezoids. So what a trapezoid is a quadrilateral that has one set of parallel lines. So unlike a parallelogram, which has two sets, this one only has one set. So right here you can see this is our set of parallel lines. One set of parallel lines in order for it to be a trapezoid. We do have a special kind of trapezoid called an isosceles trapezoid. This one does have quite a few different properties to it. So those are going to be, again, it's a trapezoid, so it has one set of parallel lines. But with being an isosceles trapezoid, the sides are congruent. Legs. The base angles are congruent. Okay. The angles, so that means these angles are also going to be congruent as well. The adjacent angles on the side, on the leg, are supplementary. That means they equal 180. And the diagonals, right there, are congruent. So let's write all those down real quick. Legs are congruent. Base angles are congruent. So that's this set right here and this set right here. Adjacent angles on a leg are supplementary, and the diagonals are congruent. All right, so knowing those properties, let's look at a few examples. Example 1, it's a trapezoid. I give you one set of parallel lines, but I also give you congruent sides. So that means it's an isosceles triangle. So now I tell you AC, which is this diagonal, is 5x minus 22. And I tell you BD, which is this diagonal, is 3x. And since they're diagonals in an isosceles trapezoid, they are congruent. So that means I can set them equal. So I will add 22 to both sides and subtract 3x. So I have 2x is equal to 22, which means that x is equal to 11. Example 2. I do not tell you that the legs are congruent on this, so you do not know if it's an isosceles trapezoid or not. But I do give you two right angles, 6x plus 22 and 4x. Now a trapezoid is also a quadrilateral, so what do you know about the angles of this quadrilateral? 4, 3, 1. They equal 360. So I'm going to set this up. 90 for a right angle, plus 90 for my other right angle, plus 6x plus 22, plus 4x. I'm going to take all four angles and add them together. So once I start working through that, 202 plus 10x equals 360. Subtract 202 from both sides. 10x is equal to 158. So x is equal to 158 over 10, or 79 over 5. 15.8 would probably be acceptable as well. Example 3. So this is one property of trapezoids I didn't talk about in other places, so we'll talk about it right here. So the line I have kind of put in here right now is EZ, and it's called a mid-segment. It's the middle of RA and TP. I'm marking that now for you, so that way you guys know that. I should probably use. There we go. All right. Now, how the mid-segment of a trapezoid is related to the bases is that it's actually the average of them. So, how I'm going to figure out what EZ is I'm going to use that average. So, if I give you 2 and 4, how do I find the average of those? Add them together, divide by 2. Same thing here. I'm going to add my bases, so 2x plus 36, and I'm going to divide by 2. And that's going to give me my mid-segment. So that's going to give me 4x plus 15, because it's the average of the two bases. Okay, so now I need to go through and solve that. I can see that 2 goes into both of these, so that means that I have x plus 18 is equal to 4x plus 15. So I'm going to subtract x from both sides. I'm going to subtract 15 from both sides. So I end up with 3 is equal to 3x. X is equal to 1. Let's confirm that that is actually the answer. So I'm going to start plugging those in to see if they work. 2 times 1 plus, and this is 4 times 1 plus 15. So that's 2, 19, and 36. So let's see if that works. Is 2 plus 36 divided by 2, 19? The answer is yes, so that is correct. I've done everything right. All right, good luck on your homework.